Hello, welcome to lesson 1. I'm going to quickly make the screen big and I will also upscale this thing so the visibility is right good for you. So in the description you can open up this link and it will take you to this page, and basically the first step we're going to do is simply run this clone. So we're just cloning the repository. We are just downloading all the files that we need for this program. So it makes our lives easy. If you go into this folder, you'll see this OpenCV tutorial folder created for us, and it has some sort of images that we will be using for this particular set. So the first step, the first lesson we want to look into is changing a color profile of an image. So the first thing you want to do is import OpenCV, and that's the mother father of everything, of all the images. So you want to download OpenCV first and make sure OpenCV is happy and it takes care of all our images to the best of its extent. Now we also want to display the images, and since we are using Google Colab, it's in order to display it right in the browser, there is a different function, and for that purpose we will import from Google, because Google had created this patch for OpenCV, and you say Google Colab dot patches. So you have patches from Google Colab patches, import CV2 IM show. Then the purpose of this guy CV2 IM show is just to take your image and display it on the browser. So as simple as that. Now you have OpenCV and you have OpenCV IM show. Now what do you need? You need the images to work on. So the first thing is to read the image. And I'll say, okay, I have an image and show me how I read the image. So OpenCV has this command called imRead. And this is basically stands for image read. This image read guy can take whatever image you have and just read it in the program in this Python application. What does imRead need from you? It only needs the path of the image file. So where is our image located? Our image is located, this is the color.jpg, this is the image that I am interested in, and it is available inside this images folder of color.jpg. So we will say, okay, I have my image, it is in the images folder, bracket, and the slash, and you put down color.jpg. So that is my image. So imRead just needs for you to guide and let him know where the image is stored. So I'm just saying it's under images, color.jpg. So it's as simple for now. Now let's try to read this image. Let's try to display this image for now. So we can use this imcv2 show command, and we'll do show, and this show only needs you to tell what image you want to show. And in our case, we just want to display this image. So we say, this is the image you want to show us. So once you have this, just go ahead and run this, and it should open up the image for us. You can see it's a very colorful, very vibrant, very displaying image for us right here in the browser. Now, I am interested in what is the dimensions of the image, what are the properties of the image. And for that purpose, let's not display it again. We write, hey, OpenCV, tell me what is the dimension, what is the property of the image. And that is stored under the function, under the variable called shape. So I will run this, and it displays this function and this number. And what is this? What does this stand for? So 476 and 640 are nothing but the number of rows and number of columns, or the width and the height of the image. And this number 3 represents the number of channels that are available in the image. Now, since this image is a colorful image, it has 3 channels, which is nothing but the red, green, and blue channel. And that is what defines a colorful image. So this is basically a colorful image. Now, the first thing we will look into, since we are talking about colorful profiles or changing the color of the profile of the image, the first thing we will look into is making an image grayscale. Now, grayscale image, what is this? It's basically a black and white image. Now, let's see how OpenCV can do it for us. So we will call a new image called gray, and we will say, hey, gray image, make this colorful image turn into gray for us. How would you do it? You just go into OpenCV 2, and OpenCV has this amazing function called as CVT color. And this color function is capable of converting the color of any image that you give. So you need to just let the function know what image that you need to provide. In this case, we'll say our colorful image from the previous section, please convert that into gray for us. So we say image, but it also needs to know what kind of color you want. So yes, I know you have given me the image, the colorful image, but what do you want in return from me? So for that purpose, we say, hey, OpenCV, convert it into a color from color to gray. So we say convert color in caps lock and an underscore. And we say, hey, OpenCV, convert it from BGR to gray. So we just say this and it converts it for us. And we say BGR because our original image is in the format of blue, green, red, all the three channels separate. And we convert it into a gray image. Coming down, let's display this image for once again. Now let's see what does the gray has in store for us. And let's run this, and voila, our colorful image is now turned into a grayscale. Now you might ask, hey Misbah, you had a very beautiful colorful image. Why did you bother converting it into a grayscale image? Why do you even need to do that? Aren't you spoiling the image? Aren't you going to spoil the program? What is the purpose of converting it into a grayscale image? The purpose for that is these three channels. So you can see the colorful image had three channels. And these three channels store information about the red color, green color, and blue color. And that is a lot of information for us. When you're going to be using OpenCV algorithms and computer vision programs, you have to do complex processing, pixel level processing. You're going to be opening each and every bit of the image. And that's too much of information for us. So in order to reduce that, one of the techniques is to reduce the number of channels. So like this colorful image had three channels. If you were to display and ask OpenCV, hey OpenCV, give me the number of what is the shape of this gray color image. And if you print this, you can see that the colorful image had three channels and the black and white or the grayscale image has no channels. So you can see there is nothing available here because it's only one matrix all by itself. It doesn't have any channels. You have reduced, you have compressed all those three channels into one channel, which is defined by a gray color profile. So you have reduced the information, you have reduced the number of pixels, you have made OpenCV happy because now it doesn't need to handle three different channels for your images. Just one image, there's just one channel, and that's all it needs to take care of. So you're making OpenCV happy, you're making your computer happy because it doesn't have to load so many bits of information for you. And this makes life easy for you and for the program. So let's go into the basics. Now we have the grayscale image. Let's look into another print, another type, and that is the HSV image. Now you might ask, okay, so we took out all the color profiles. We took out everything we needed from the color images. Now we brought them into a gray image. But what if I was interested in color? I am a colorful person and I am interested in identifying different colors in my image. And that is my project. but you made it into grayscale. Now, how am I going to work on it? Well, to answer it for that is your HSV image. And this HSV image or this HSV channel is capable of holding all the color profiles under one channel. Now, what do I mean by that? To appreciate that fact, remember this. Your colorful image had three channels, right? Blue, green, and red. The HSV image will also have three channels, but the channel that defines the color is only present in one bit. So I'll explain what that means. But let me say, hey, OpenCV, I'm going to create a new image called HSV. And for that purpose, I want you to convert my original image. And I'm going to use again this convert color profile function. And I'm going to pass OpenCV the colorful image that we had, image. And we're going to let, hey, OpenCV, this original image that I have, convert it into a HSV image. The HSV color BGR to HSV. And if I just print the shape of this HSV dot shape, and let's run this. So you can see HSV also has three channels. So what are we doing then? Well, HSV stands for hue, saturation, and variance. And the hue is defining all the color profile in the image, all the colors that are available. Blue, green, red, everything, all the colors of the rainbow are going to be available in this just one channel called each. So if you can control, if you can pinpoint H to give you red color, you can also pinpoint it to give you yellow color, green color, blue color. So this HSV guy, the H channel of this guy can hold all the colors of your image. So previously, this colorful image had three channels, and in order for you to define a color yellow, you would need all the three channels to define what a yellow color looks like. But a HSV image can only use your H channel to define what color you need. And that makes your life in detecting colors very simple, very easy, and very easy for the computer to process. So your complex algorithms that we will look into the future will be very easy to run. You might ask, how does this HSV image look like? Well, you don't want to see it, but I'm going to do it anyways, and you might regret. Let's run this. And you can see that this HSV image looks nothing like the colorful image, nothing like the grayscale image. It has its own legend, and it's running, it has an own property, it has its own way of displaying images. And that is what we are interested in. We are going to look into the H value, the S value, and the V value separately to define the color that we are interested in. So with that, we come to the conclusion of our first chapter, which is changing the color profiles. And these are the color profiles that are going to help us in our later projects.